Proportional controls.
Analog
The idea
systems
behind
communicate
proportional
with variable
control
frequencies.
is that it is
For
simpler
instance, for
than
every
most
yes or
types of
no
automatic
applying a
control
system,
system,
an analog
whilst being
system
as
would have a
effective.
maybe.
A
The maybe
proportional
in this
control
case
system
is
takes
noise.
an error and
Noise
adjusts
is the
accordingly.
signals
For example, if a car is moving too fast, the driver will slow down to the right speed by adjusting their acceleration.
Such as the fuzzy
Proportional
interference
control
when
is
listening to an
replicated in
analog
the
radio.
coding of sensor signal conditioning.
Examples.
For example, if a fish
Recording
tank
devices
heating
such as
system
tapes
detects that
or
the water is
VHS,
too warm for the fish to survive,
landlines,
it will heat the water
comms
less
like
and therefore
walkie-talkies,
cool it down to the correct
and
temperature.
most old digital systems
It will make
like
sure it's the
old
correct
TVs
temperature because
that have been
1.
upgraded.
The water temperature will be taken again by the
Digital
thermistor,
systems.
and 2.
Digital systems
It will
use
cool the
very
water
simple
down
binary
proportionally
signals,
to how
i.e. they
overheated
give
the
a
water
definitive
was
yes or
to the
no
target
answer
water
when sending
temperature
a
set for
signal.
the fish tank.
Digital systems are used today because they are easier to make, cheaper to make, and they are precise. They don't have the noise interference that analog systems do. An example of a digital system would be a TV, nowadays TV, a radio, CDs, DVDs, Blu-rays, mobiles, and computers. When comparing both forms of system, you can look at it this way. Digital systems give binary signals in a way that the signal can only ever be in two states. Whilst this is an improvement on temperamental analog systems that have an in-between state, some form of analog interference needs to be introduced to everyday users so that the system is usable. Analog systems are much more unreliable due to the fact that the signal represents a sine wave, which sends data through the frequency of its waves, and cannot be trusted to always get its signal through interference, thanks to the noise that comes between the peaks and the troughs in the analog wave signal. Control loop operations. There are 4 different parts in control loop operations. So firstly, control operations. Control operations are commands. They are either based on input into open control loops or are based on feedback from the outputs in closed loop operations. Sensor signal conditioning. Sensor signal conditioning is mainly used in closed loop operations where a sensor provides feedback which is added to the control system's output and used as the input for the next loop. For example, a sensor could sense that a room needs to be 1 degree warmer than it is to meet the certain user-defined needs. Therefore, the next control loop, the control system will heat 1 degree more than previously. Output. The output in a control system is meant to be what the user wants. In an open loop control system, if the input is wrong, the loop system will continue to do the operation wrong until a new input is acquired. In a closed loop operation, the system will automatically detect the issue through the use of sensor signal conditioning and correct its own input by basing it on its own output. Simulation. Simulations help to initially develop control loop operations. Once a condition is simulated, a control loop can be pre-programmed to respond to the simulation before being implemented into a control system. For example, a plant feeder can be pre-programmed with the knowledge of what a plant needs to grow, and can bear that in mind when its closed control loop alters its own inputs, so the plant isn't over or underfed.
Proportional controls. The idea behind proportional control is that it is simpler than most types of automatic control system, whilst being as effective. A proportional control system takes an error and adjusts accordingly. For example, if a car is moving too fast, the driver will slow down to the right speed by adjusting their acceleration. Proportional control is replicated in the coding of sensor signal conditioning. For example, if a fish tank heating system detects that the water is too warm for the fish to survive, it will heat the water less and therefore cool it down to the correct temperature. It will make sure it's the correct temperature because 1. The water temperature will be taken again by the thermistor, and 2. It will cool the water down proportionally to how overheated the water was to the target water temperature set for the fish tank.